the instantaneous velocity of the particle at time 2. So when you're taking like the time, let's say 2 is around here, you just go down and you see the whole slope. So you take your time from and your displacement from there. So here we have 10 for the displacement and negative 20 for the displacement, and we have 0 and 3. So just using the formula, negative 20 minus 10 over 3 minus 0, so you should get negative 10. Um, so for part B, the instantaneous speed of the particle at 2 seconds. So the instantaneous speed is essentially the instantaneous velocity, but without the direction. So it's the same thing, but just instantaneous speed is a scalar quantity. So if it's a scalar quantity, that means you can't put a negative, meaning it's going to just be the same thing but positive. The instantaneous velocity of the particle at time 4 is, so at time 4 we can see that the line is here, and at time 5 and 3 they're both at negative 20. So if they're both like at negative 20, do negative 20 minus negative 20, you're gonna get 0, meaning that if you're gonna get 0, that means the answer's gonna be 0. Like you can't do 0 over anything. The average velocity in the time interval 0 seconds and 4 seconds to 1 decimal place is. Okay, so let's just follow the line. So at time 4 seconds, it is 14, not 15. And at time 0 seconds, it's 0 over there. So just applying the formula, you do 4 minus 0 and then 14 minus 0. So 14 over 4 is 3.5. So for part B, the instantaneous velocity at 2 is. So basically for instantaneous velocity, you can take, any points on the tangent line, meaning this straight line. Take any 2 points. So you can take points, for example, 1 and 0 and 2 and 3. So over here. So you can do basically 3 minus 0 over 2 minus 1, and you'll get 3, which is your answer. The tangent point 10 seconds in 5 passes through point 4 seconds in 0. Okay, so you're just gonna do the formula again. So 10 minus 4 over 5 minus 0, so you get 5 over 6, which is 0.83. The initial velocity of the car is 20 meters per second. It decreases to 2 meters per second in 3 seconds. The average acceleration in an object's, so they're asking basically for the formula, so it's going to be velocity over time. So the average acceleration of the car is, so it's again change in velocity over time. So 20 minus 2 over 3, so 18 over 3, which is 6, but it's going to be negative 6 because it decreases to 2 meters per second. So negative 6 because it's decreasing. What is the average velocity of the particle in time interval 0 seconds and 3 seconds? Okay, so for this one, just over here, let's say time 0 is okay at 0. So far we have 3 minus 0 over the time at 2 is 2, so 2 minus 0. So I'm at 3, but essentially if it's at 3 it's going to be here, so it's also going to be at 2. So 2 minus 0, which is 2 over 3, which is 0.67. 2.9 to 2.10, which car is moving faster at the start of motion? It is car A because it is higher on the graph, like from the velocity side, looking at the velocity, it's higher. Which car ends up farther from its starting point? Car B. Which car experiences a greater magnitude of acceleration? Car A, because again it's higher on the velocity point. And for part B also, you just have to like read the graph for this one. Select the VT graph, which describes the following motion. A car accelerates from rest in the positive direction, then moves at a constant speed before slowing down and going back to rest. So it's speeding up, meaning it's going to go up. Then it moves at a constant speed, meaning it's straight. And then when it's slowing down and going back to rest, meaning it's moving down, meaning it describes the first graph. The graph below shows the velocity of a particle at different moments of time. The average acceleration of the particle at time interval 0 seconds and 5 seconds is blank meters per second. Okay, for this one, you just do the formula for velocity, which I told you before. So you just have to do 5 minus 0. So 5 minus 0 over, uh, following the graph, you get 4 and you get negative 5. So negative 5 minus 4, so you get 9 over 5, which is 1.8. And for the instantaneous acceleration of the particle at time 1 is, okay, so let's say time 1 is roughly around here. So following the line, the whole line, our time here is 2 and 0, so 2 minus 0 over 12 minus 0, so 12 minus 0, so the answer is 6. The instantaneous acceleration of the particle at time 3 is, so let's say time 3 is around here, so following the line, 5 minus 2 over 0 minus 12, so you get negative 4, which is the answer. The net displacement of the particle during the 6 seconds is, okay, for this one they're asking for the net displacement, so in the 6 seconds, so it means you need to find the net displacement for all of this. So let's just split this shape into 3. So our first shape is this triangle. To find the area of a triangle is length times width over 2. So we're doing 10 times 2 over 2, which is 10. And then switching the color over here. For this shape, to find the area of a rectangle, it's just length times width. So 10 times 3, which is 30. And again, we have another triangle over here. Wow, I just use the same 3 colors every single time. So 10 times 1 over 2, so you get 5. So just add 10 plus 30 plus 5, and then you get 45, which is the net displacement. The speed of an object at time 0 is, for this one you just have to read the graph. So here we can see at time 0, just following up, we can see it's 30. And the speed of an object at time 20 is, following the graph, we can see it's just 0. So this one's just basic reading of the graph. The distance traveled in the last 5 seconds. Okay, so let's just, the last 5 seconds is from 15 to 20, so this is the shape we get. So length times width over 2, 70 times 5 over 2, you get 175. The total distance traveled in during the 20 seconds in 975 meters. What is the average speed of the object during the 20 seconds? So for this one, you just need to use the formula for average speed, which is um, distance over time. So distance over time, so 975 over 2, which you get 48.8. In phase A, B, the object is, so it's going upward, meaning it is speeding up. In BC, it is in a straight line, so it's moving uniformly. CD, it's moving downward, so it's slowing down. And in DE, it is moving uniformly because it's in a straight line. The average acceleration of the particle in the time interval 0 seconds and 4 seconds is. Okay, so for this one, just the formula for average acceleration. So 4 minus 0 over negative 2 minus 0. Again, we're just following the graph if you cannot. So you get negative 0.5. The displacement of the particle in the time interval 0 seconds and 4 seconds is. So when they ask for the average acceleration, they want you to use the formula, but if they ask for the displacement or the net displacement, then they want you to find the area of the shape. So 0 seconds and 4 seconds, so here. Hold on, let me draw that better. Okay, so here we need to find it when it's, so we can split this into two shapes. This is a rectangle, so length times width, so 5 times 2, which is 10. And then length, for the triangle, length times width over 2, so 5 times 2, which is 10 over 2, you get 5, that means your displacement is 15. The stopwatch is turned on as a toy car passes the 3 meters mark on a track. The toy car is moving at in the negative direction at a constant speed of 0.40. The position of the toy car at 2 seconds is blank. Okay, so for this one, we're just going to use the formula for URM, which is position equals initial position plus velocity times time. So our position we need to find, and our initial position is 3 plus our velocity, which is negative 0.40 because it's set in the negative direction, multiplied by our time, which is 2. So you should get 2.2 as your answer. Okay, 2.11 to 2.13. A particle at the origin starts from rest, accelerates at 2 meters per second squared. The particle would be 81 meters away from the origin in blank seconds. Starts from rest and accelerates at 2 meters per second squared. The particle would be 81 meters away from the origin in blank seconds. Also, I forgot to say this is 2.11 to 2.13. So for this question, you're going to need to know the formula. Displacement equals half of acceleration times squared plus velocity times time, initial velocity times time. So replacing, you get 81. Displacement equals half of 2 times, we're gonna call time h, plus the velocity, which is 0 because it's at rest, times h squared. So doing this math, you should get, eventually you should get time squared equals 81. You can also just like plug it into your calculator, and then doing that, the square root of 81, you get 9. A cyclist accelerates from 20 seconds at a rate of 0.40 meters per second. She then travels at a constant speed of 460 seconds. Sorry. Okay, so for part A, we're gonna use the formula for so velocity equals initial velocity plus acceleration times time. So sorry, I meant for UARM. So after just replacing, we can get velocity equals 0, starts from rest, plus 0.40 times 20. So you should get 8. For part B, the net displacement of the cyclist during the entire motion described is blank meter. Now we're going to be solving for the second part of the equation, which is going to involve using this formula equals half of AT squared plus VI times time. I'm not going to keep it up because there's not going to be enough space. But just replace, so you get 0.20, time, half of 0.40 times 0.20 squared plus, 20 squared plus 0.20. So after just doing the math, basically you should get this equal to 80. Now we can use the formula for URM. So displacement equals VT. It's basically the same thing, but it's basically this, but you just take this to the other side. So you just have to do that, and after replacing, you get this equals 8 times 60, because they want the net displacement, right? So you get 480. So our first displacement, which we got, was 80, and our second one was 480. So you just add those two together, you get 560, which is the answer. A cyclist on his bike accelerates from rest and reaches a speed of 6 meters per second in 25 seconds. Then he applies to the brakes and comes to rest after moving through 20 meters. Okay, so for part A, we have to use the formula V equals initial velocity plus AT for the first leg, yeah? So, first leg. And after replacing, you should get A equals 6 over 25. Of course, like you have to move A to the other side and yada yada yada. So you should get 0.24. So the acceleration of the bike after applying the brakes is blank meters per second. Okay, so for the second part, we have to use the formula velocity squared equals initial velocity squared plus 2 times displacement times acceleration. So just essentially replace. So 0 squared, because it comes to rest after moving, equals 6 squared plus 2 times 20 times h, which is going to be just acceleration. Okay, let's just call it a just to make it all confusing. And after solving, you should get negative 0.9. A particle initially moving at 12 meters per second is decelerating at 3 meters per second squared. The displacement of the particle before coming to rest is blank meter. So we're going to use the same formula as last time. So velocity squared equals initial velocity squared plus 2 times displacement times a. So we'll just replace and solve. So we need, so you get 0 because it's decelerating, so we're gonna end at 0. So 0 squared is literally just 0. 12 squared plus 2 times, we're gonna call this h, so times h times acceleration, which is 3. After solving, we should get 24. The time it takes the particle to come to rest is blank. So for this one, we're going to use this formula. Velocity equals initial velocity plus acceleration times time. So 0 equals 12 plus 3 times time. So you should get 4. A jogger continuing to run at a speed of 2 meters per second along a straight path. So there's speed, so it's going to be velocity. A hammer falling near the surface of the moon. That's going to be, it keeps on glitching. That's going to be non-zero acceleration. A cart moving in a straight line gaining 5 meters per second each second. Acceleration because they talk about velocity. A box suddenly sliding down an inclined speed of 0.8 meters per second. That's gonna be velocity because you're sliding down. What is the distance covered by the truck when it reaches a speed of 72 kilometers per hour? Okay, so for this one, we're gonna use this formula. Squared equals initial velocity squared plus 2 times acceleration times displacement. So again, before we even start using this formula, we need to convert this into meters per second. So we divide it by 3.6. So you get 20. So that means meters per second. So 20 squared equals 0 squared because it's starting from rest plus 2 times 1 times h, which is this. So 200 equals 2h. 400 equals 2h. So you get 200. Okay. To land safely, a jet linearly accelerating uniformly at 7 meters per second runway with a minimum length of 500 meters. What is the maximum touchdown speed of that jet linear? So we're going to use the formula which we used in the last question, and the final velocity is going to be 0 because it's deaccelerating, and it's also going to be equal to -7. The acceleration is going to be negative. We're going to call this x squared plus 2 times -7 times 500, and after solving you should get 83.7. A cyclist accelerates from rest for 20 seconds at a rate of 0.40 seconds. She then travels at a constant speed for 60 seconds. I think this was the first or second question. Wait. Yeah, so I'm not doing this again. A toy car initially moving at 2.50 meters per second in the positive direction starts deaccelerating at the rate of 0.20 meters per second squared. The velocity of the car 2 seconds later is what? So basically this whole quiz is just trying to understand which formula to use when. So if you guys want extra practice, go search up like UARM formulas on Google. But the only way to like truly master this topic is by like applying it and practicing it. So anyways, this is the formula we're going to use. So velocity equals 2.5, initial velocity plus -20, 2.0, um times 2, not 2.0, oh my god, 0.2. So after calculation, let me just write that down better. Let me just record. Like, what the hell? 2.50 plus -0.2 times 2. So you should get -0.4 squared. -0.4 minus 250. So you should get 2.1. The cyclist, oh my god, passes the line with a speed of 2.80 meters per second in the positive direction while accelerating at a constant rate of 0.2 meters per second squared. The displacement of the cyclist in 20 seconds is blank. Okay, so for this one, it's really easy. Just apply the formula. Is initial velocity, half of 80 times initial velocity times time. So just replace it. Two, wait, sorry. Half of 0.2 times 20. Finally, I did not get twisted when I said that. Squared 2.80 times 20. My handwriting is actually really bad. So just after solving, you should get 96. So